Good afternoon, students. Firstly, I will introduce myself. I myself, Professor S.H. Chaubey, working as assistant professor in Electrical Engineering Department of S&D College of Engineering, Yola. So in the last lecture, or when actually you know that we are seeing the subject that is the high voltage engineering. So when we have seen the high voltage engineering, in this case, we have seen that unit 1 is nothing but the breakdown in the gases. Breakdown in the gases. Unit 1 that contains the breakdown in the gases. So now, in the breakdown in the gases, we have seen firstly the gases as an insulating medium. It means that what are the properties of the gases that they should be adopted or they should have for as an insulating medium. Now, second, what we have seen, the important is the types of the ionization. In the last lecture, I have given you some idea about the ionization, how the ionization takes place, what is the different processes for the ionization. So in this lecture, in the last lecture, we also seen there are types of the ionization. Types of the ionization. There are 4 types of the main ionization. That is the first one, ionization by collision. Second one, photoionization. Third one, secondary ionization. Fourth one, electron attachment process. It means that in the last lecture, we have seen that 2 types of that one. First one, ionization by collision. And second, what we have seen, the photoionization. So in this lecture, we will see the third one, and that is the important one, is the secondary ionization. In the secondary ionization, before going the types, what are the different types of the secondary ionization, I will give some idea that what is the secondary electron, why it is called as a secondary ionization. It is called as a secondary ionization because of that it happens or it causes due to the secondary electron. Now, surely the question comes in your mind, what is the secondary electron now, this one? What is this? So in this case, in the last lecture, when we have seen the ionization by collision, at this time we have seen one diagram, if you remember, that there is one cathode, one anode, and electrical supply, E field supply E is given to that. When the E electrical field is supplied to this circuit, then this time what happens actually? The electrons are released from the cathode. Where will they go? Surely they will go to the anode, because anode is positively charged. Like charges repel each other, and like charges attract each other. It means that this electron will reach to the anode. So actually what happened? What should happen? It should happen that the number of electrons that are releasing from the cathode must be equal to the electrons that are reaching to the cathode, to the anode. The number that's released from the cathode must reach to the anode. That is source. That is simple. But actually in practice, what happened? The electrons that are reaching to the anode are more than the electrons that are released from the cathode. And these electrons that are more, which are reached to the anode as compared to the electrons that are released from the cathode, is called as the secondary electron. And the collision or this ionization takes place by these electrons is nothing but the electrons secondary ionization. So we will see the first one, the electron emission due to positive ion impact. Now, in the case of collision by ionization by collision and ionization by photoionization, last 2 topics, we have discussed something. So what happened in this case? The electrons are released. As the electrons are released, it means what happened? Positive ions are formed, and they travel where? Now again, they are traveling in the reverse. Now they will travel to cathode, because now they are going to positive ion. Positive ion will be surely attracted to the cathode. So where will they reach? They will reach to the cathode. And this, when the positive ion approaches a metallic cathode, it causes emission of the electron from the cathode. And this is nothing but the simple ionization due to the positive ion impact. What is the name? Positive ion impact. It means there is an impact of the positive ion on the cathode surface, and due to this one, the electrons is released. So it is called as the electron emission due to the positive ion impact. See the simple diagram for that one. In the diagram, we have seen that positive ion, see in the diagram, positive ion is arrow is shown to the cathode. Electrons, the arrow is shown to the anode. That is going to be the electron emission from the cathode. It means this ion, in this case, the positive ion that is reaching to the cathode causes this one, single one here one. Here see this one. This is a positive ion, it is reaching where? Cathode. And due to this one, what happened here? See, one electron is released from the cathode. And electron emission from the cathode is nothing but due to this positive ion. So it is called as the electron emission due to positive ion impact. This is the first one. Now we will go for the second method. Second method, the electron emission due to the photons. What you know that the photons will come, where will come from it? It will come nothing but it will come from the ultraviolet light. You see here that it will come from the ultraviolet light of suitable frequency. So what happened? If the electron is to be dislodged from the outer shell, it should be given enough energy so that it overcomes the surface potential barrier. It means the surface potential barrier that is restricting the electrons to be released should be overcome. And for this purpose, what happened? Enough energy must be given to that one. And this energy is going to be supplied in the form of photons of the ultraviolet light of suitable frequency. Where is it from? Photons of the ultraviolet light of the suitable frequency. And in this case, see the diagram. The photons are bombarded on this one. See here. Here, see the photons is given. These photons are bombarded. This is the conducting charge. This is the metal. And these are nothing but the free electrons. Firstly, these free electrons are contained in that metal. Now what happened due to this bombardment of this photon? See here on this one. There is an emission of the electron. And this emission of the electron is called as a secondary emission, secondary ionization. And this is due to the photons. So it is called as the electron emission due to the photons. See simple diagram. I have shown the photons. I have shown the free electrons. And in the last one, what I have shown? I have shown here the emission of the electrons. After the bombardment of the photons, what happened? There is the emission of the electron. And what is the ionization? Ionization is nothing but simply the emission of the electron. So this is going to be the second one, that is the electron emission due to the photon. Now we will come to third one. Electron emission due to metastable and neutral atom. This is the third method of the secondary ionization, that is the electron emission due to metastable and neutral atom. Now surely when we are going to see what is this metastable? What is this metastable? Metastable atom or molecule is an excited particle. Metastable atom or molecule is an excited particle. What the comparison of normal and metastable? The difference is that the lifetime of such metastable atom is very large as compared to the lifetime of the ordinary particle. Surely the lifetime of this metastable atom or molecule is more as compared to ordinary particle. So what happened? They have the more energy. So in this case, the lifetime is very large. The lifetime is there. It means they can easily reach from the cathode to anode because their lifetime is more as compared to ordinary particle. So in this case, there is an ejection of the electron from the cathode due to this one because of this metastable has the more lifetime as compared to the ordinary particle. So it is going to be the metastable. And the electrons can be made to eject from the metal surface by means of impact of excited atom. What I have told you starting. What is the metastable atom? what is the metastable atom or molecule is nothing but an excited particle. So due to this one, the emission of the electrons takes place from the cathode. So it is called as the electron emission due to metastable and the neutral atom. And this is the third type of that one, that is going to be the secondary ionization. What we are saying? Secondary ionization. And the last and the most important portion of your the secondary electron, and that is the last one, is that electron attachment process. What is this electron attachment process? You know that some gases are electronegative in nature. What is this electronegative nature? Electronegative nature, it means they have the attraction for the electron. Up till now, what we have seen? We have seen that. Up till now, what we have seen in the second, this breakdown in the gases, the ionization takes place due to the release of the electron. But in this case, what happened? There is an electron attachment process. It means that some gases are electronegative. They are electronegative, it means they have the affinity for the electron. It means they will attract the electron. They have the affinity for the electron. And this is called as the SMC here. Some gases are electronegative in nature. They have affinity for the electron. They are electronegative, it means they have the deficiency of the electron. As they have the deficiency of the electron, it means they are having the affinity for the electron. And this is called as the electronegative gases. Attachment collision is process in which electrons may become attached to the atoms of the molecule to form the negative ions. This is called as the electron attachment process. So in this case, what happens? Some gases are electronegative in nature. It means that they have affinity for the electron. Attachment collision is a process in which electron may become attached to the atom or the molecules to form the negative ions. It means one day, up till what we have seen, up to this process, there is the formation of the positive ions because electrons are released. Now in this method, what is their electron attachment process? It means there is the affinity for the electron. It means they are going to attract the electrons towards them. And this is going to be the electron attachment process. It means electrons are not released. Electrons are attached to the gases. And so it is called as the electron attachment process. Electron attachment process depending on the energy of the electron and the nature of the gas. What is the nature of the gas is very important. Because just starting what I have told, that some gases are electronegative gases. Electronegative, it means they have the affinity for the electron. It means they are going to be get attached to the electron. Up till now, what the different process we have seen? We have seen that there is a release of the electrons from the atoms or the bottom molecule. In this case, what happens? There is an attachment of the electrons from the other gases to this gas, electronegative gases. So it is called as the electron attachment process. So in this case, we have seen the total secondary ionization. Now, in the next lecture, we will go into important portion that is going to be the Townsend's primary ionization. In the next lecture, we will see what is that Townsend's primary ionization. Always remember that there are two processes mainly in the case of breakdown in gases. Townsend theory, and that is going to be the second one is the Stevens theory. These two theories are very important in the case of ionization, or in shortly, you can say in the case of breakdown in the gases. Two theories are important, Townsend's theory and second one is the Stevens theory. So thank you students. In the next lecture, we will see this Townsend and the Stevens theory. What do you end? जमा क्या? हाँ? जमा क्या सर?